Right, and welcome back to 2024 question B2. So we've got a developments question here along with some orthographic. Actually, and a bit of conics thrown in there as well. The image on the right shows a salad packaging box. The salad box includes a series of planar surfaces and a clear plastic window as shown. Figure B2 shows the development of a similar salad box, including a clear window which is in the shape of an ellipse. So we've got our ellipse window here, and it's folding down around two surfaces. And they want us to draw the given surface development of the salad box without the elliptical window to begin with. So just the outline here of what's given. Now I can just see here later in the question say on a separate drawing due to orthographic projection. So I'll maybe do that over on the right hand side, and I'll keep my developments over on the left hand side. I should fit it all into one page. So we want to first of all just draw the outline of that, excluding the ellipse. Right, so start with nowhere in particular, should fit it into this side, no problem. So I'll start with the top. Okay, so we'll make that 110 long. Come in a little bit, yeah, that'll be fine. Yeah. So 110. And let's project that down, and we'll need that way further down here as well. So I'll project that lightly down a good distance of the page there. Okay, we also have the depth there is 80, so I'll measure my distance of 80. And we'll have our fold line there. And all around the outside. Alright, so it's the first part of it. 42 down, 50. So I'll start actually measuring these down. 42. There, got 50 and 42 again. All right. And we've got 15 and 15, so I'll measure in 15 and 15. So I can actually draw the outline. Hidden detail of what is the base. Okay, and let's join the diagonal and diagonal. That's 80 long, so that's going to be, that's 15 out this way and 15 this way. Okay, so 40 here. Okay. Draw this base as well, because I've got those positions. Okay, so just tipping along, putting in what we can. And we're getting to a point now where we're actually going to have to use a little bit of construction, nothing crazy though. Right, so I know the width across there and there is 80. I have the base, but that line there, we don't have a distance out to measure. All right, we do know that when this folds up, okay, this is the side, front, back, okay, it forms that edge there. Okay, so the length of this and this is equal to that length, and you can see it with the arc being swung there. So they've even given us a hint towards solving that. So I'll get my compass, set it to that distance, and swing that back onto that mark. I can do the same on this side. And yeah, so now I can finish those off. I've got those positions. So part A, pretty straightforward. We're just redrawing what's given to us in the question. Right, nothing very difficult there. Yeah, so that's part A completed, excluding the window. Now, RS, so RS is the major axis of the elliptical window. Okay, major axis, minor axis. P is a point on the curve, so here is a point that they've given to us. Determine the length of the minor axis and draw the curve. All right, let's find RS first, RS and P first of all. So, actually need to put in a center line. Right, we've got a center line there on the question. It'll just make it easier for us. So center line that way. If you want to put it in using the line dash, you can. And I've got a center line going this way too. Okay, we might use them as references later. Okay, so up 20. And that is going to give us the position of RS, which can be drawn horizontally along, and it's 90, so it's 45 either side. Right, so we've got R and S. Okay, P is down in 35 along that line, so P. P there. Okay, so that's the points they've given us. Now, determine the length of the minor axis. So we have to determine the length of the minor axis before we can draw the curve. So this is kind of working in reverse. If you get my pen here. So normally when I'm drawing an ellipse, I have my concentric circles, my major and my minor, and then I draw a line out until it hits the major axis, okay, or major circle, and I can draw a line up, and then where it hits the minor, go across, and that'll find me a point. So that's our point P. Now they're giving us point P, and they want us to find this circle here, right? So we're going to work in reverse, right? We are going to draw out, from P, right? We're going to draw down until we should draw our major circle to begin with. So we'll draw down until we have a major circle, join that back to the center, draw a line across, and that'll find me my minor circle. I'll be able to draw the rest of the shape then. So leave that down. Major circle, first of all, compass set to 45 mil. There's my major circle. All right, we are going to draw a line down onto major circle and join that back to the center. Okay, and now we already have a line going back. So there, that is the length of my minor. So I can set my compass to the minor length and swing an arc, swing a circle around like so. So I know it's not coming out very heavy there on your or on the camera, but we've got our major circle, our minor circle. Let me see, can I get a bit? No, it's not really coming out there. Okay, you can just about see it. Right, so let me split up 60-30. My concentric method for drawing, or concentric circles method for drawing an ellipse. All right, so I split it up. And now where these divisions hit the major circle, I draw towards the major axis. So I'm going to draw down towards the major axis, towards major axis. Same here, towards. All going towards the major axis, and then where it is the minor, we can extend across, find the minor, right, so we're finding points around like so. Okay, point R is a point. Okay, and P is obviously a point there. So we'll draw our freehand curve. So if I'm drawing a freehand curve, I'm looking at the point I'm traveling to. So not the point of the pencil, look at the point I'm traveling to. As I hit that, my eyes dart to the next point. That'll get us a nice, neat, gradual curve. Okay, so there's my ellipse. So part B completed. Now, on to part C. On a separate drawing, draw the orthographic projections as follows of the solid box when the box has been assembled. So when it's all folded together. So we're essentially drawing this here. And we're looking in that direction, in the direction of the arrow. So the elevation in the direction of the arrow. So part 1 there. Come up here, we'll just draw our XY line. We'll be able to transfer any distances. We will a little bit. Right. So let's draw my XY line. Okay. All right. So I want us to draw the elevation to begin with. Okay. Have we got distances? Yeah, we have distances we can use already given to us in our development. So let's start with those. All right. We can draw the base. Yeah, we're asking for the elevation first. They want us to draw the base, which we know is a length of 80. So we can actually start using our compass to take distances from here, but we'll go 80. This is the length of my base. I'm actually going to put a center line there because we had a center line for our drawing. And that's fine. The width then was 110 for the top element, so that's going to be 55 to the left, 55 to the right. Okay. Yeah. Project those down. Don't need that, we'll project that down. Here's our center line. So base, the top part. All right. Now, the length of that side. Okay, the length of that side is going to be given to us from this view. Okay, so imagine this is folding up and we're looking at the side of it. So this is going to be the height folded up. Okay, so I'm actually going to get that distance on my compass, which is, give it to us, they didn't. That's the distance I'm taking. Okay, and that we'll find there. Right, so that's going to give us our edge view of that surface. Right, I'll actually project that across. That'll be a heavy edge. Yeah, all the way across. All right, and then join that down. Elevation drawn in that direction. Now, do we need to do the ellipse projections? Yeah, so we'll have to include the ellipse. All right, so that's it folded up and around. So I'm going to have this little lip folded down. You can see it there. So it's folded down around the front, which is going to be this portion here. All right, I've got my center line, got my true lengths, sloping out towards it. Right, so let's find point P anyway, first of all. So it's going to be out 35. So it'll be a corresponding point P out on the opposite side. That's finding those 2 points there. Now we need to find the heights of those on a sloping surface. All right, so that is going to be achieved. So we need to find points. Okay, we could project those onto an edge. We have those edges. Yeah, so I can project those onto the edge here, right? We have that edge, so I could get that distance and swing it off. Yeah. Okay, so yeah, we're going to find points now. This distance, yeah, actually we won't be projecting onto that because this surface is going to be folded up, or sorry, they're all going to be folded up and it'll be sloping. So though that's not the true shape of that, but we will be able to find that distance and mark it off on the edge. Okay, so let's start with this point. All right, that point there, that distance, okay, we can step off here and bring that across. We already have our center point, so that's going to be there. Okay, we've got 2 more corresponding points here, so let me just actually get those heights, get those distances, get them, that distance again, on the edge, swing an arc, and they'll be somewhere along there. Now we've got the distance out, we can find that true length there from my development, and I can swing an arc to find those. Yeah, so that's going to be my freehand curve. there like so. So that is complete elevation, direction, A. That's all of the elevation completed. Right? A plan projected from elevation and include all hidden detail. So project some down. Let's go with the outline anyway of our base. So take some distances from here. My base was 50. Now I'm actually going to project that across and we'll just draw it in this position. So I don't have to measure the 50. So there I've got my hidden detail base. I'm going to see those edges. I won't go those hidden detail just yet because we might see some of those when we look through the plastic element, right? So now we need to find the outside, right? And that's going to be that shape down here. We know that's 110, right, which we've got measured off, and the width of it, bring it across my center here. The width or depth of it there, it was 80. So we're going to go 40 down 40. Right. Okay, and we're going to have some hidden detail right from each corner. A bit of work in this question now. Development questions, usually there is a good bit of drawing, kind of thinking about where we're going to find true lengths from and things like that. Right, and that is where that meets. Right, so we can go heavy as far as that. Okay, so yeah, we'll go ahead and detail down this back surface too. Yeah, I won't go any further than that because I know I'm going to have some elements that I can actually see here. Right. So what we want to do now is we want to draw our ellipse. So that's actually going to be, this true shape is actually what we're going to have on the top here. I've got my center. So we've got, let's find the center there, which was up 20. That's going to be up 20 from the edge of my, yeah, so it's there. And we'll draw our line out. RNS then, that was 90, so let's go out 45 either way. And that's fine, yes. R and S again. Okay. I could start taking, which would be quicker. Okay, just to do something a little bit different, I could basically use the concentric circles method to draw that portion of the ellipse up there. But I'm actually going to take heights and distances. Okay. So I'm going to bring back these points together because it's all going to be symmetrical. Yeah. Right. So what I'm going to do is I'm going to take, to find that point, I'm going to take that distance, step it up, take that distance, step it out. All right. So let's go with that. So we go, that's the outside point, then we get the next one in. It's here. Next one in. It's here. And that's actually going to be down here as well. Right, so there are kind of reference lines. Right, that is a point. And now I can take the distance out to there. That's there and there, and there and there. I might need to extend some of those a little bit. And we've got distance 1 and 2 there. Just extend these out a bit. All right, so I have points now that I can draw. Like I said, you could have just used the concentric circles method, but I just wanted to show you something a little bit different. So let's draw my freehand curve. Okay, and we're actually going to see all these edges in here. Great, so this is coming together now. I think I just have one more part to do, which is this curve here, which we'll get from the elevation. Okay, so I need to find points. We've got them here. Yeah, so I can just bring those down, those points down onto this edge, bring them across, and I'll be able to find them there. So it's just using orthographic views now to finish this off. Okay, so I've got that point, and let's bring this point down and this point down. Yep. So I've got my freehand curve and my freehand curve. Right, so that is all that question completed, yeah. So including hidden detail, check my hidden detail. Yeah, right, so that was a nice question there. There's been more difficult development questions in the past, so it wasn't too bad, but nice one there with a bit of conics thrown in for good measure. Right, so that was 2024 question B2.